All right, get this. A team of scientists is planning to do something that sounds, well, completely insane. They want to drill straight into the magma chamber of an active volcano. We're talking about getting face to face with molten rock, thousands of degrees hot, bubbling right under our feet. But this isn't some crazy stunt. It's a mission that could literally change the way we power our world.
So that brings us to the big question, right? Why on earth would you do that? Why would anyone risk waking a sleeping giant, spending millions of dollars just to poke a hole into a pool of molten rock? What could they possibly be looking for that would justify that kind of risk? Well, that's what we're here to figure out.
Now, this isn't just some rogue operation. It's a massive, organized effort with a name that's just as ambitious as the goal itself: the Iceland Deep Drilling Project. And what they're attempting is a true world first.
The place? The Krafla volcano, up in northeast Iceland. The year? 2026. That's when this incredible scientific mission is set to begin. And if they pull it off, it will be the very first time anyone has gotten direct measurements from inside one of these super hot, high-pressure magma chambers. But to really get why they're doing it here, you first have to understand Iceland itself.
So, why Iceland? I mean, of all the places on Earth. Well, it turns out the country's unique geology makes it the perfect natural laboratory for this kind of experiment. It's a place where the planet's raw power is quite literally bubbling to the surface.
See, the entire island of Iceland only exists because it's sitting smack dab on top of the Mid-Atlantic Ridge. You can think of this as a giant seam on the Earth's crust, where two massive tectonic plates, the Eurasian and the North American, are constantly pulling away from each other.
And the way the country was formed is just fascinating. As these plates drift apart, hot rock from the Earth's mantle rises up to fill the gap. When it gets closer to the surface, the pressure drops, and that rock starts to melt, turning into magma. That magma pushes up and erupts, and over millions and millions of years, all those eruptions have piled up to build the island we see today.
And this isn't just some abstract geology lesson. You can actually see and feel the results. It creates these amazing natural geothermal wonders like the Secret Lagoon. I mean, it's basically a giant natural hot tub that's been geothermally heated for people to swim in since 1891. So this heat is a gift, but trying to tap into it at the source, well, that comes with some serious risks.
Which, of course, brings us to the elephant in the room. Isn't drilling into a live volcano incredibly dangerous? The short answer is yes. Yes, it is. The number one risk is exactly what you think it is: accidentally triggering a massive eruption. The science behind it is kind of like shaking up a can of soda and then popping the top. See, magma has all these gases dissolved inside it, held in check by incredible pressure. If you drill a hole and suddenly release that pressure, those gases can expand violently. They can shatter the magma into tiny particles of ash, creating a huge, dangerous ash cloud.
And don't let the word cloud fool you. Volcanic ash is basically microscopic bits of rock and glass, and it is serious trouble. Back in 1989, a British Airways flight lost all 4 of its engines when it flew into an ash cloud. Many of us probably remember 2010 when an eruption right there in Iceland spewed so much ash it grounded flights all across Europe. And on a planetary scale, massive eruptions 52 million years ago changed the entire global climate and helped cause a mass extinction. So yeah, the stakes here are incredibly high. So how are the scientists possibly going to manage a risk that big? Well, they were very, very smart about where they chose to drill. They did their homework. The magma at this specific site, Krafla, is thought to be much older, meaning it's had a lot more time to release most of its explosive gases. That little detail dramatically lowers the risk of a catastrophic eruption, making this whole thing a lot more predictable and, well, a lot safer.
Okay, so let's say they've minimized the risk of a giant explosion. Great. There's still the tiny problem of, drilling through rock that is literally molten. How in the world do you even do that? The engineering solution here is it's brilliant. So the challenge is obvious. Magma can get hotter than 1,000 degrees Celsius. That's 1,800 degrees Fahrenheit. It would melt a normal drill bit in seconds. So the solution? Instead of trying to fight the heat, they're going to use it. The plan is to actively freeze the magma right in front of the drill, creating a hard protective shell of volcanic glass, they're calling it a magma sock, that shields the equipment as it pushes deeper.
So, with all this risk and all this mind-bending engineering, we have to ask again, what is the ultimate prize? Why go through all this trouble? The answer has to do with a very strange state of matter and what could be a revolutionary new source of energy.
The whole goal is to get to something called supercritical water. Now, this sounds like something out of a sci-fi movie, but it's very real. Under the insane heat and pressure you find near a magma chamber, water does something bizarre. It stops being a liquid and it stops being a gas. It becomes this weird, powerful hybrid of both at the same time.
So why does this strange water matter so much? Well, because in that supercritical state, water can hold and carry a phenomenal amount of energy. It becomes this incredibly potent, super efficient vehicle for moving heat from deep in the earth up to the surface where we can use it.
And this is where it gets really exciting. A normal geothermal well, a good one, might produce about 5 megawatts of power. But a well that taps into this supercritical water, we're talking about a potential output of 50 megawatts. That's not a small improvement, that is a 10 times increase in power from a single hole in the ground.
To put that number into perspective, what does 50 megawatts actually mean? It means a single one of these wells could generate enough clean, reliable electricity to power around 50,000 homes. Think about that. One well powering a small city. That's a total game changer.
And that's why this isn't just an Icelandic science project. This is a potential blueprint for a brand new era of clean energy for the entire world.
The promise here is just enormous. Unlike solar or wind, geothermal is on 24/7. It's a steady, reliable source of clean power. We could get way more energy from way fewer wells, which means less impact on the environment and a much better financial return. And it creates a perfect pathway for skilled workers from the oil and gas industry to transfer their drilling expertise directly into the green energy sector. But, okay, let's be real. We're not quite there yet. There are still huge hurdles to overcome. We need to keep developing new technologies and materials that can actually survive these extreme environments for long periods. And taking this from one experiment to a global energy solution, well, that's going to need a ton of investment. But that's precisely why this project is so critical. These scientists, they aren't just drilling a hole, they are digging into the future of energy. They're pioneering a path toward a world powered by the clean, immense heat that's already churning away right beneath our feet. And so, that brings us full circle. An idea that started out sounding reckless, totally crazy, drilling into an active volcano, is now looking like one of the most brilliant, most promising steps we can take toward a clean and sustainable future. It really leaves you with one last powerful thought, doesn't it? We are right on the edge of unlocking a nearly limitless source of clean, powerful, sustainable energy that exists everywhere, right under the ground we're standing on. The question isn't really if we can do it anymore. The real question is, what's stopping us from harnessing it everywhere?